What is the uniform properties assumption in closed thermodynamic systems? Imagine trying to understand how a sealed container of water heats up or cools, done without having to look at every tiny part inside. That's where the idea of the uniform properties assumption comes into play. It's a simple but powerful idea used in thermodynamics to make analyzing systems easier. When we say a system is closed, it means no mass enters or leaves the container, but energy can flow in or out as heat or work. Now, the uniform properties assumption says that at any given moment, the temperature, pressure, and density are the same everywhere inside the system. This means the entire container acts like a single, uniform object, even if it's actually made up of many tiny parts. To understand why this assumption is useful, think about a pot of boiling water. If you heat it slowly and stir it well, the temperature throughout the water becomes the same. This is because heat spreads quickly and evenly, making the water uniform in temperature. In thermodynamics, we assume this uniformity to simplify calculations. Instead of dealing with complex variations inside the system, we treat it as if all properties are the same everywhere. This makes it easier to find out how much energy is stored, how much work can be done, or how heat transfers happen. This assumption also ties into the idea of thermodynamic equilibrium. When a system reaches equilibrium, the properties like temperature and pressure no longer change with time or location. The uniform properties assumption is a way of saying the system is in that state. It's especially valid when the system is well insulated or mixed thoroughly, so no gradients or differences exist. For example, in a sealed tank of water heated slowly, the temperature can be considered uniform. However, in real life, things can be more complicated. During rapid heating or in very large systems, properties might vary from one place to another. In those cases, the uniform properties assumption is just a simplified model. Engineers and scientists use it to make initial calculations and predictions, knowing that more detailed models might be needed for precise analysis. In essence, the uniform properties assumption in closed thermodynamic systems means that all the key properties like temperature, pressure, and density are the same throughout the entire system at any moment. It's a handy way to treat complex systems as simple, uniform entities, making the study of energy and work much more manageable.